Hello, we are going to be working on lesson 2-1 using graphs to relate two quantities. And so when we analyze graphs, the first thing that you always want to do is you want to look at the title of the graph and you want to look at the dependent and the independent variable and try to be able to see the graph and interpret the data fairly quickly. And that's what the goal of this first page of our notes is. So in looking at this first example, it says the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? And then describe how the variables are related at various points on the graph. So I'm going to do this in two different ways, okay, when I describe. But the first thing that you want to do is you want to identify the variables. Our variables are time and volume. So time, which is represented on the X or our independent variable, and volume, which is represented on the Y-axis, our dependent variable. So let's look at this graph. What is actually happening? Well, if you start to blow up a balloon at 0, it has 0 volume, right? And the more that you're blowing up the balloon, the more time that goes by, the higher the volume. But then what's happening here on these constant parts? Most likely the person is trying to take a breath. Okay, so as I describe this graph, I might write something like, someone is blowing up a balloon while periodically taking breaths until what happens at the end? It pops. So that's what we're going to write right here. Okay. Now, there is another way that sometimes you will see, and you might see this in your homework, you might see on graphs where they've labeled the different sections of the graph and they describe each section. So what does this look like? I might consider this A, and this is B, C, and D. And then I might label this D, E, F, and then this straight line G. And then sometimes they'll describe each letter and what's happening. And so I'm going to briefly do that here just to give you an idea of what that looks like. Okay, so at A, B, C, and D, air is blown into the balloon. Okay, now I'm going to describe D, E, and F. And oops, D, E, and F. The person is taking a breath. And then we could say that at G, the balloon pops. So either way works in describing the graph. Just remember that if you're creating a graph and you want to describe it and use this method in blue, that you will need to mark your graph up. Okay, let's go to the next one. Here we have just instructions are to interpret the graph. What's going on here? And then it asks for our variables. So our variables are time on the x-axis and water used on the y-axis. So what we're seeing is that over time, more and more water is being used, but you'll look and see that this is a straight line, which means that it's being used at a constant rate. And so something that and you can create your own scenario because it doesn't give us any specifics. So I thought of a pool filling up at a constant rate of change of 5 gallons per minute. And where did I get that 5 gallons per minute? Well, if you look at the graph here and you do slope as rise over run, here we have 1 and here we have 5. So if I go from 5 to 10, I'm rising 5, and then I go from 1 to 2, I'm running 1. So my rise over run is I'm rising 5 and I'm running 1, which gives me a constant rate of change of 5. Okay, so let's go ahead and write this out. A pool is filling up at a constant rate of 5 gallons per minute because our time is minute and it's going up by gallons. Okay. And so that's pretty much how I would describe that. Some people want to just describe the X and the Y as X increases by 1, Y increases by 5 at a constant rate. But when you're dealing with a real world situation, you want to use words and describe that real world situation rather than describing the X and the Y, what's happening on the X and the Y. Okay. All right, let's go to our next graph. Now, this graph does not even have a title, and all graphs should have a title. When you're working on your homework, you need to make sure your graph has a title. It has increments on both the X and Y axis, and it has the labels on both the X and Y axis. So let's look at this. What could possibly be happening with our speed and our time? Now, when some people look at the speed where it's just a straight line here, they think, oh, they're not moving. But that's actually not the case. If you look, they're going 50 miles an hour over the course of a certain amount of time. And I kind of think of that as cruise control on a car. Okay. So they're on cruise for a while and then they start to slow down. So maybe traffic has slowed a little bit. And then they're going at a really slow pace. So they're going at 30 miles an hour for a little bit. And then maybe they get on an off ramp and they're slowly coming to a stop until they hit the stoplight. So that's kind of what I think of. Now, some people can relate this to other situations. This is just what makes most sense to me. Okay. So, and because we're talking about speed and time, we are talking about a real world situation. So that's how I'm going to describe it. So let's look at our variables. Our variables are time on the X axis and speed on the Y axis. And I'm going to go ahead and describe my graph based on the situation I just went over. So also what I'm going to do is I'm going to go ahead and label my graph A, B, C, and D. And then I'm also going to label this at E. So sometimes that helps me when I'm describing my graph. So here we go. At A, a car is driving at a constant rate of 50 Now it's 50 miles per hour. Okay. That's what I'm going to go with, miles per hour. And then at B, slows down to 30 and drives at that constant rate for some time. We don't know what the time is. Okay. Then you could say at D, the car slows down until it comes to a complete stop at E. Okay, that was a lot. Oops, and you can't see that. So let me move this down. I'm sorry about that. If you are watching the video, you can go ahead and pause it to get all of this down. So this is one way to write it. I am going to show you what I've done before, which is just a different, it's a briefer way or less wordy way. So here's another time I did this. At A and C, a car is going at a constant rate. At B and D, the car is slowing down. And at E, the car has stopped. So that's just another shortened version of how to describe a graph. Either way is okay. It doesn't matter as long as you're understanding the graph properly. Okay. So that is page one when you're using a graph and you're describing it, you're reading it. Okay. Now we're going to go to page two where we're reading about a graph and then we're going to sketch it. Okay. So let's go to page two. So when sketching a graph, you always want to identify the two variables and give it a title. That is really important. Okay. So identify the two variables that are being related. And add this up here. Number 3, give your graph a title. You always want to do that. Okay. So let's look at example 1. You're going to label a graph with the proper X and Y axis, then sketch a graph that represents this situation. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. So I want you to think about this. Okay, and I'm going to read it as I model it with my hand. Okay, so a model rocket rises quickly and then slows to a stop because the fuel's running out. Okay. And then it starts to slowly come down or maybe quickly come down. And then the parachute opens. When the parachute opens, I don't know if you've ever seen somebody in a parachute or when they're falling out of an airplane and the parachute rises, but they quickly rise up and then slowly start to go again. And so that's what our graph has to look like. So let's do this. We're going to go ahead and just sketch the X and the Y axis and give it a title. All right. So we have our graph that may look something like this. Does not have to be perfect. Notice I'm not using a ruler. That is okay. All right. And we have to determine what our X and our Y axis is. So it's rising. So we think height would be 1. And then it's taking a certain amount of time to fall back down to the ground. So we're going to have our height and our time. So time is on the X axis. Height is on the Y axis. Now, we don't know any specifics. If we were doing this in real life and testing it, we might be able to have, use a stopwatch to figure out the time and then somehow measure the distance as the rocket flies up. But we don't have that information, so we're going to leave the increments off. And then give it a title. I'm just going to put model rocket. You can come up with something more interesting if you would like. Okay. So here is my graph. Now I'm going to start sketching it, and mine may look a little different than yours, and that's okay. The general idea should be about the same. So as I sketch, I'm going to read. So my rocket starts at the ground. So it's going to start down here. Okay. And the rocket shoots up in the air, goes quickly. And then, and some of you, you might have a steeper hill. I don't know, just, you know that it's rising. And then the parachute starts to slow to a stop and fall. But then what happens? The parachute lifts up. So it quickly goes back up, and then it starts to fall again. Okay. And that's pretty much what your, something similar to that. Now, what I'm going to do is I'm going to go ahead and label the parts of the graph that match the problem, just so we can get an idea of what's happening. So the model rocket rises quickly. So here, the rocket is launched. Okay. And that is right here. And then right here, it slows to a stop. And that would be right here. And then here, we're going to do an arrow. It falls quickly because that's what it tells us. Right here is when the parachute opens. And then here it falls slowly. Falls slowly. Maybe my curve here should have been a little more going that way, probably. Okay, but this is just a general idea of what a sketched graph would look like based on information given. Okay, now we're going to go to example 2. It says sketch a graph to represent this situation. Temperature from January to August. Okay, so we have increments in months. We have January to August, but we don't have actual temperatures. So we don't need to put temperatures on there unless you want to as just a general guide of what you think the temperatures truly range for in Texas. And we're going to think Texas because that's where we're at. All right, so I'm going to start sketching my graph here. And I'm going to leave room on the bottom to represent so that I could put my months. In this case, we're talking about time, January to August, or months, and then temperatures. And your temperature depends on the time of month it is. So your temperature is the dependent variable, which goes on your y-axis. So over here, I'm going to put temp. And then at the bottom is our months. Now, to make this a little bit easier when I'm sketching my graph, I tend to turn my graph to the side like this so that I can write out my months. So January, February, March, April, May, June, July, August, September, October, November, December. Okay, you don't have to write them all. And notice they're not perfectly distributed because we're sketching. Okay, so then I just will write a little abbreviation. January, February, March, April, May, June, July, August, September, October, November, December. Okay. And then temperatures. Now, I said you don't have to have temperatures, but I'm the type of person is I need to see a guide. You don't have to, but I'm going to go ahead and put my increments, and I'm going to go in increments of 10. So I'm going to do this. I like to do it better this way. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, now that doesn't mean that we can only go up to 90 degrees. It just means that that's as far as my graph went. And I actually think I need to make it a little bit longer. So I'm going to sketch it up just a little bit more. So 90, 100. Okay, so let's fill in those increments. 10, 20, 30. All right. So now I need to give my graph a title. And I know it doesn't say Texas temperatures, but I'm going to put Texas temperatures because that's where we're at. And that's how I'm going to base my graph. So Texas temp. All right. So let's go ahead and plot our points. And we can estimate this. So let's say, now we did have a really big snowstorm last year, and I think it got down into the 40s or 30s or 20s. It had been about 20s. So now typically I think February is colder than January. So you're going to see a dip from January to February, and then it's going to go back up. So in January, I would say it's somewhere between 40 and 50 degrees. Let's make this easy, and we're just going to put 50. Now, last year when we had that huge snowstorm, it did dip way down. So I'm going to come down here in February, and I'm going to dip it about 30. Might have been colder than that. I can't remember. And then in March, it was maybe an average of 45. Okay. Remember, this is just a sketch. You don't have to be perfect. In April, we're going to say, let's see, what would be April? Maybe 60? Maybe 55 or 60. In May, let's go up to maybe like 70. In June, oh my goodness, it's probably 90. May could be more closer, maybe closer to 80. 90. July is probably high 90s. August, you'll hit some 100 temperatures, but the average isn't usually 100. It's usually in the 90s. And so I've gone to August. So now what I'm going to do is, because this is a line graph, I'm going to go ahead and draw my line. Okay. So, and so this is something similar to what you might have. Now, when I've done this, I'm going to show you what I did before, because we didn't have that big snowstorm. It really didn't get too cold. But this is something like what I've done before. And so it was more of a slow rise from low to high temperatures. Okay. So sometimes it might look different. That's all I'm saying. All right, let's go to our third graph that we're going to create. This one gets a little bit more detailed. So graph the situation. Cupcakes cost $15 for the first 5 cupcakes purchased. Each additional cupcake costs $4.50 each. Sketch a graph with the correct variables, title, and a graphed line. Now, because this gives us details, I'm going to want to form a table to figure out what my increments are going to be. Then I'm going to sketch my graph. Okay, so before I do that, I'm going to place my graph right about here. And that leaves room for my table over here. So I have X and Y. Now, let's look at our little equation up here. So what is X going to represent? Well, the total, we're looking for the total cost based on the number of cupcakes sold. So how about we do this? Number of cupcakes is our X, and then cost would be our Y. Okay. So let's say we bought, well, let's start with 5 because it looks like we have a 5 minimum here. And then we bump it up to 6, 7, 8, and let's stop right there. Okay. You really only need 2 points on a graph, but on this one, I'm going to use a little bit more. So at 5 cupcakes, and we could write our equation right here. We could say that the total cost equals $4.50 per cupcake plus the $15 for the 5. Okay. So if I bought 5 cupcakes, I'm looking at just $15. So that actually isn't the correct equation. Let me take that off. That's a little, let's see. So if I only buy 5 cupcakes, I'm paying $15. If I add a cupcake, then it's going to be an additional $4.50. So I add $4.50 to this and I get $19.50. Okay. Then if I add another cupcake, I add $4.50 to this and that is $24. And if I add another cupcake, it would be $28.50. Okay. Let's do 9 and 10. Let's see what we get here. 9 cupcakes is going to be 33 and then 38.50. Oh, is that right? Yeah, 33. Oh, this one isn't right. I was like, something's wrong here. This one is 37.50. Okay, now I have increments, I have my X and my Y, and I just need to give my graph a title. So let's go here. We have number of cupcakes. And on the y-axis, we have total cost. And then I'm going to just put cupcake fun. Okay. Now I'm going to put my increment. So when I look at my x-axis, I know I'm going to go all the way to 10. So I'm just going to estimate this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then for my cost, I have to go all the way up to about 40. So I would say that we could go up by, I would like to go up by 2. That might not work out. So let's go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Okay, now I'm going to fill in my increments. Okay, now that I have this, I can just plot my points over here. So if I buy 5 cupcakes, it's about $15. So we're just going to estimate that a little bit. So about right there. 6 cupcakes is almost $20. So we're going to just eyeball that. 7 cupcakes is about 24. So we're going to be right under 25. So maybe right there. Then 8 is about 28. So we're going to maybe about right there. 9 is about 33. My points are probably a little bit off. And 10 is about 37. Yeah, I'm a little bit off, but that's okay. So then when I plot my points, it's going to be up like that. Okay, so that's just a sketched graph of what this situation will look like. Okay, we're going to go to the back. And what I would like for you to do right now is I would just like you to read example 1. You're going to read this situation and you're going to try to match it to a graph. I'm going to give you a minute to do that. And then we're going to come back and you're going to check your answers. So you might want to pause the recording. Okay, you should have circled this graph right here. So opposite Tom's home is a hill. Tom climbed slowly up the hill, walked across the top, and then ran quickly down. Okay, so over here they have no quickly down, so that one's sort of obvious. Okay, let's go ahead and go down to example 2. We're putting a table and graph and descriptions all in one. So let's look at what this says. It says a band allowed fans to download its new video from its website. The table shows the total number of downloads, 1 through 4 days. Which graph could represent the data shown in this table? So you're trying to match a graph here with the table. So graph blank matches the video downloads, graph A, B, C, or D. So the first thing I want to do is I want to analyze that table a little bit. Every day you're going up one day, but how much are we going up between each day? So let's look at this. From 346 to 1011, it's approximately 700. From 1011 to 3455, it's approximately 2500. And from day 3 to day 4, it's approximately 7,000. Okay, so you can see that it is consistently going up, but it's not going up at a constant rate of change, and we never see it go down. So let's look at our graphs here. We have this graph that goes up at a constant rate. Well, this isn't going up at a constant rate, so that can't be it. This one shows that it's going up slowly and then quicker at the end. That's kind of what this graph is doing. Let's look at this one. This one is showing that it goes up, but then it starts to level off. This never has leveled off yet. And now this one starts at a lot of downloads and then slowly decreases the downloads. Our downloads here don't decrease. So what that's telling me is that graph B matches this table. Okay. Now what I'm going to do is we are going to go through and we're going to describe each one of these graphs. All right. So on this one, we can see that there is a constant rate of change. So that's the first thing I'm going to write. Constant rate of change. And another thing I could say is that for every day added, the downloads increase. Okay. So every day, the downloads increase. Okay. Some may say that as X increases, so does Y. Okay. So another way, as X increases, Y increases. Now, because this is a real world situation, we would not use this. We would only use that if we're given just a blank graph and a blank table with only X and Y values. Okay. Let's look at this one. Is this a constant rate of change? No. So you might say that every day downloads increase, but not at a constant rate. So let's write that. Okay, so that would be B. Now let's look at C. Again, this one isn't at a constant rate of change. X is definitely increasing, but Y increases until it starts to level off. Now, let's describe that with day and downloads. So as each day passes, the downloads increase until it starts to level off. That's pretty much how I would say it. So as each day passes, the downloads increase until they level off. It's typically how it is, though. Really, I think this is more representative of how how a real world situation would be when a new song comes out and then the downloads are just boom, boom, boom. They increase, but then they start to level off because a lot of people have already downloaded it. And so that looks more like a typical, but maybe it doesn't start to level off until day 10 or something. Maybe at the beginning it rises quickly and then it starts to slow down. Okay. And this also infers that it's not a constant rate of change because we said until it levels off. All right, so this one is a constant rate of change. But it's saying that the downloads decrease every day at a constant rate of change. That's what this one would be. So downloads decrease at a constant rate of change. You know what? I'm going to put downloads decrease each day at a constant rate of change. Okay. So that concludes lesson 2-1. You could go back and you can pause the video as you're doing some of the problems to help you. But that concludes our lesson.